Welcome everyone, and thank you for joining today's session. I'm excited to introduce this webinar hosted by Pentera Labs, the research division of Pentera. At Pentera Labs, our mission is clear: to uncover real-world attack techniques and vulnerabilities. Our team of seasoned security researchers dives deep into the latest exploits and tactics and integrates these insights directly into Pentera's platform. This enables organizations to continuously test, validate, and strengthen their defenses against ever-evolving cyber threats. Today, we'll unpack our latest finding: new injection points tied to the IngressNightmare vulnerabilities, a critical Kubernetes issue first uncovered by Wiz. I'm proud to introduce Ron Okopnik, who uncovered these new injection points. He'll guide us through the research, the risks, and what it means in practice. Ron, the stage is yours.
Thank you so much, Shako, and I would like to start with a quote from Einstein: "When the vulnerability is published, always look for more." And now for a word about myself. My name is Ron. I'm a cybersecurity researcher at Pentera. I'm a computer science and mathematics BA student. I have 6 years of experience in cybersecurity research, and I'm a really die-hard fan of You. Great show on Netflix, recommend everybody to watch it. So our today's agenda would be first diving into how nginx works. Then we'll see attackers' train of thought regarding finding those new injections. We'll see Wiz's disclosed injections and go through our new injection points we found during our labs. So what's ingress-nginx? Basically, ingress-nginx is an open source Kubernetes project that basically manages external access to our backend services pods within the Kubernetes cluster. And if you are wondering what I just said, then let's imagine together a traffic junctions. Basically, inside the traffic junction, we have a lot of cars trying to reach their destination, but we need to guide them to get to their destination, and how to get to that destination, and whether they're allowed to, and if not, what should they do? For this case and all of those problems, we have the ingress-nginx to be there and control all the traffic. So now that we understand why we need nginx, let's look how it works. So inside the ingress-nginx pod, we have two main services. First, the admission webhook. The admission webhook is the part of the nginx that receives all of the new rules and configurations and prepares a rule set for the nginx service, which then would get all the rules and manage the traffic according to them. So let's start with the admission webhook. How does it work? Well, at start, a user sends a JSON of admission object to the admission webhook. Then the webhook receives the JSON. It creates a configuration file out of the JSON and out of configuration template. Then the webhook performs an nginx-t, a test on the configuration to see if it's valid or if it has any syntax errors. And while it runs the nginx-t test, all the directives in the configuration are executed. Directives are some kind of special commands within the configuration, and some of them are very important. For example, the SSL engine directive, which we will dive into today. This specific directive allows us to load SO files into the nginx service. SO files are some kind of DLL files, but on the Linux operating system. This is an example of how the webhook performs its work. On the left side, you have the configuration template. And on the right side, you have a new configuration template after the webhook received data input from the user and created the new configuration. Just for now, notice how the new configuration is built from scopes, and each scope is made by curly brackets, opening and closing. So Wiz did a great job making their research and finding new injections, but we tried to do it ourselves in our labs. So According to their research, Wiz has found 3 injections: auth URL, auth TLS match CN, and mirror UID. All of these are annotations, or as you can say, settings inside the configuration that can be injected. Let's dive into one of them, specifically the auth URL one. According to Wiz's research, the injection inside auth URL is very simple. You just add a semicolon and get to the injection point. But when trying to do the same thing in our labs, we failed. And the error message stated that the SSL engine directive is not allowed here. So I wondered to myself, what does here means, or why is it not allowed there? So I went back to the configuration and took a good look. So this is how the configuration looks like. And we can notice again that all of those scopes are configured by closing and opening curly brackets. So what if we abuse those curly brackets and thus get to run our directives? So we started by ending just one closing curly bracket and then getting to the injection point. And unfortunately, we got the same error message. But what if we tried more? After some tries, we got to the point we added 3 closing curly brackets. And finally, we reach an error message. But this time, the error message is caused by a different error. Apparently, we were actually able to load the SSL directive and run it, but unfortunately, we just need to give it an SO file. So for now, we were managed and able to run our own directive on the nginx pod. So great success, right? And during mimicking and replicating the Wiz research in our labs, we actually managed to find some new cool findings. And how did we do it? Well, very simple. Because nginx is an open source project, we started by going to the documentation, and we started by picking an interesting annotation of string type, so we can write characters into it. And we looked if it has any prerequisites. So inside the annotation documentation, we chose just any random annotation. For example, permanent redirect. After that, we checked the parser inside the Go project of Kubernetes ingress-nginx. So going back to the open source project, we opened that annotation and started digging deep inside the code. So going from the annotation, right here, we got to the annotation validator. And from the validator, we found that it uses a special regex called URL is valid regex. And keeping diving into the code, we finally found that the regex allows some special characters, specifically the closing curly brackets and semicolons. Sounds great. So what now? Now we would find the annotation in the configuration template and calculate the escape characters accordingly. Going back to the configuration template, we would locate where that specific annotation rests. Then we would try to see how many special characters this same closing curly brackets we need to add just to escape the scope and be able to run our directive. And then just edit and see how it looks like. So in this example, we have just some arbitrary data, semicolon, 3 curly closing brackets, and then the injection point itself. Now we would add the escape to the JSON and run the exploit. So in order to get the JSON, we would need to craft it. But we just downloaded some admission JSON from the internet and added our own annotation to it. As you can see, we just added annotations tab, and under that, our own permanent redirect annotation, some data, and then our escaping characters, and finally the injection itself, the SSL engine injection. After that, we would check inside the nginx logs if we managed to run the directive, just like we did earlier. So first we would go into the configuration. We can see that we indeed got outside the scope, so we can theoretically run the directive. And inside the logs, we can see the same good error message we received before, which states that the directive was run, but we did not supply it an SO file. So we finally advanced to the point where we need to get an SO file. So how do we do it? How do we ship the SO file to the nginx pod? Well, first of all, let's figure out which SO file we need. What will be our SO file? And in this case, our SO file would be a very simple C file, which we will compile, and we'll just open a bash terminal on our attacking machine. And now we need to find a way to ship it to the nginx service. And how would we do it? Now this is the part where we go inside deep the nginx service and find it has a really cool ability. Any message you will send to the nginx service, the nginx service will save the content of that message into one of its processes under a random file descriptor. File descriptor is very similar to a handle in Windows, if you're not familiar with. So we just have to send our malicious SO file and then load the correct process and file descriptor, right? Sounds easy. But unfortunately, no, because we need to determine which process has that specific file descriptor. Thankfully, we have a great and inspiring technique called brute forcing. We would just go through each process, and for each process, we would go through each file descriptor and just try to brute force our way one by one to get to that SO file loaded into the file descriptor. Sounds cool. Now let's combine it all together. On one end, we have the forge JSON, where we'll have our injection and then the SSL engine with the combination of the process and file descriptor. We will be sending it over and over and over again, each time with different combination of a process and file descriptor. Then, on the other hand, we will have the malicious SO we send to the nginx service, which it will load into a specific process and file descriptor. Looks great. Now let's look it in live in a demo. Right now, I'm on my attacking machine outside the Kubernetes cluster, and I will just start listening on port 443 using netcat. Going back to the Kubernetes cluster, I will execute inside an Ubuntu pod, and then from inside that random Ubuntu pod, I would activate the exploit. Notice that the exploit has 3 arguments. The first one is the URL of the nginx service, where we will send to our malicious SO file. Then the second attribute would be the nginx control admission webhook, which will brute force again and again the process and file descriptor combination. And finally, our own attacker's IP to put inside the malicious SO file to get back with the reverse shell. Now, activating the exploit, you can visually see how the brute force is taking place. And we are guessing one by one for each process. We're going through all the possible file descriptors, one by one, until the exploit ends. It takes about 3 to 5 minutes. And then we can go back to our attacking machine. And voila, we got a reverse shell on the nginx pod. And running a simple whoami command will result in the www.user, which is the user that the nginx pod uses to run itself. Great. So what now? Well, since the nginx pod is a highly privileged pod inside the Kubernetes cluster, the only thing stopping you now is your imagination. You can do almost whatever you want and compromise the cluster in whatever way you can. For this example, I just did a simple curl request enumerating all the secrets of that Kubernetes cluster. But you can absolutely do whatever you want, however you want. So, do you have any questions so far?
Hey, it's good to be back. That was a great session, Ron. Thank you. We do have a few interesting questions from the audience, and the first one will be, were you able to replicate the other injection points Wiz found?
Yeah, in fact, I was. I had to use the same train of thought I explained earlier to understand and get the correct calculation of escape characters. But finally, I managed to replicate all of those injections and find 3 new on the way.
Nice. Another question that we got was, what should we do to mitigate these new injection points?
Well, to mitigate actually all of those injection points, the simplest thing you can do is just update your ingress-nginx. Some sites suggest that you should do some other solution, some complex coding or removing some data or parts of the nginx, but don't do it. It can just ruin your nginx, cost you money, time. Just update it. It's very simple. It's very easy.
Right. Keep it simple. Another question, this time a bit more technical. When brute forcing the file descriptor of the SO file, did you find a pattern or a way to make it more specific?
Well, I actually did. I noticed that most of my tries, most of the times, the process which held the right file descriptor was between process PID 15 to 20. So I tried to most of the time focus on that. But if you want a more robust and cover all the process, I just recommend going through all the possible processes, just not to miss anything special, or just don't waste your time.
Okay, thank you. And one last question that we got was, is there a potential for more vulnerabilities to come out?
Yeah, I actually encourage everybody to just go inside the nginx, Ingress, or any Kubernetes project, since it's open source, and you can by yourself go there and examine the project with your own eyes and your own lab and environment, and just try to find as many bugs and vulnerabilities as you can, and of course disclose them, because that's how we actually make the world safer and our products better.
Great. And that's all the questions that we received from the audience. So you can continue now.
That's it. Okay.
Yeah.
I would like to end again with a quote from a special person. When the vulnerability is published, don't forget to update. That's the best thing you can do. Thank you, everyone. You were a great audience.